Right. So let's try a few substitution rule problems. To integrate, we use substitution rule, right? Because some integrals is not straightforward. So then we use that substitution rule, particularly for a problem like this, natural log. Now here, key here is identifying the correct substitution. But how would you identify the correct substitution? That's the main, most important part. And in this case, let me do something like this. For this integral, let's say I equals, I would like to express this integral like this. Natural log of x times 1 over x dx. Then, if you observe carefully, now this 1 over x and natural log of x, there is a relationship between those two, right? Because the derivative of natural log of x is 1 over x. Let me write that here. Hence, if I want to, I can write this integral like this. Natural log of x times the derivative of natural log of x dx. I just replaced this part by this, because both equal. Right? Now observe this pattern, very, very important. Now, after creating a form like this, or after identifying a form like this, you can easily choose the appropriate substitution. That is basically this part, natural log of x. Because here we have the derivative. Hence, now I am going to write my substitution, u equal natural log of x. So we use substitution for a reason, to simplify the integral, but we should convert the entire integral into a new variable. Now that is u. So we should convert dx to du. So to do that, we can differentiate both sides of this u equals ln x, natural log of x substitution with respect to x. Some people write like this, 1 over x, or someone can differentiate like this. That's also correct. Right? After that, I think you can easily identify du equals to 1 over x dx. Hence, for focus on this part, this is the integral that we are going to integrate. Yeah, of course, that integral equals to this. But we did this to identify the correct substitution. After identifying that, we can use this original integral. Right? So my advice is creating a form like this helps us to find the correct substitution. Right? After that, we can use that u substitution for this yellow colored part. Right? That is basically natural log of x is u, 1 over x dx, that is basically du. So u du, we can easily differentiate, you can easily integrate u to the power of 1 plus 1, u squared over 2. plus c. Here u equals to natural log of x. Whole thing squared over 2 plus c. That's the answer. Very important, identifying the correct substitution, because after that it's quite easy computing the integral, right? Now the interesting thing here is, now after solving this problem with that exposure, you should be able to complete this question. Let's say j equals to natural log of x whole thing squared. I like to express like 1 over x dx. Always try to express these integrals as a product. That way you can see things clearly, right? Now again, observe this 1 over x part. That's the derivative of natural log of x. Right? In other words, I can deform that natural log of x squared into two functions, x to natural log of x, natural log of x to natural log of x to the power of 2. So this is the outer function. This is the inner function. More often we use a substitution for inner function, that is natural log of x. So, and you can confirm that by writing 1 over x as the derivative of natural log of x. Like this. This pattern is quite important. Then you can use that substitution, u equals natural log of x. Then we can easily integrate because du equals to 1 over x dx, very similar. Equal to u squared du. So j equals to this. We can integrate u to the power of 3 over 3 plus c, and u equals to natural log of x. That's the answer. Right? So observe this form. That's quite helpful. Creating that form, right? Then this part here, this part, this function, that's the substitution. After creating that form, you can easily identify the substitution. If you want to, let's try to differentiate this answer. Don't worry about c because the derivative of c is 0. So I'm going to differentiate natural log of x to the power of 3 over 3. You can take 1 over 3 out. Then I think we can apply chain rule because this is a composite function. Initially differentiate the outer function. For outer function, that is x to the power of 3. That's the outer function. That's a different topic, right? If you have doubts, I'll explain that later with a different video. Now, natural log of x to the power of 3, the outer function is x to the power of 3. So when you are differentiating the outer function, please fix this. This part, natural log of x, that one acts like x. For example, we initially differentiate x to the power of 3, but x is natural log of x. So like this. 3 natural log of x to the power of 3 minus 1. Then we move towards the inner part of the function, basically the inner function, that's natural log of x. Differentiate that one. Like this. Now 3 and 3 can cancel. Of course, we can simplify this slightly. Now, if you can observe these two, this part and this derivative, basically the same thing, right? So hence the derivative of this function equals to this. Hence the antiderivative of this answer is the original function that we did differentiate. So like this. Now I think if you think carefully, you can understand why did I create this form initially to identify the substitution, right? Okay. But always try to create that form. It's quite helpful. Right. You can try that for the previous program also. Try to differentiate this function. You will see this pattern, this part. You will be able to identify those patterns. That really helps. Yeah? Instead of applying trial and error method, you can find substitution using this kind of a method, because you can apply this for any problem. Yeah. Now this third one, again, I think we can try this one. A general case of previous two problems. To integrate this, again the same idea, 1 over x dx. So I would like to express like this. Now here, again, focus on this part, natural log of x to the power of n. The inner function is natural log of x. That's very important. Then here we have the derivative of the inner function. Right? Once again, that form. That's very important. That form. Then you can use a substitution. Afterwards, it's quite easy, I think. Right? Again, u equals natural log of x. I think you can continue that process. You will get something like this. Try this one as a practice problem. Then u to the power of n plus 1 over n plus 1. Actually, I should mention here, n should not be equals to minus 1. There is a reason. Because we can't apply power rule of integration when n equals to minus 1. Right? We can discuss n equals minus 1 case separately. Plus c. Then we can replace that our original variable, natural log of x to the power of n plus 1 over n plus 1 plus c. That's the final answer. So when n equals to minus 1, that is natural log of x to the power of -1 over x. I can move natural log of x to the denominator to make that exponent positive. 1 over x natural log of x dx. I think once again, the same idea, we can apply that idea. 1 over natural log of x, 1 over x dx. This part, this is the key here actually. 1 over x. That's the derivative of the inner function. Maybe can be difficult to understand sometimes, but this is a composite function. The outer function is 1 over x. That's the outer function. If you want, I can draw that function. X2 natural log of x, that's the inner function. Then natural log of x to 1 over natural log of x. The outer function is basically 1 over x. Right? So we oftentimes we use substitution for the inner function. So our substitution should be u equals natural log of x by 1 over natural log of x. This is the derivative of natural log of x. Like this. Then we can, once again, that same pattern. Right? So you can use u equals natural log of x here. Then 1 over u, du equals to 1 over x dx, hence du. But here we can't use power rule because n equals to -1 if I move that u to the numerator. Can't apply power rule of integration for this. But we can use natural log integration because we know that the antiderivative of 1 over x equals to natural log of x. Hence here, natural log of u plus v. We put that absolute value because natural log defined only for absolute value, only for positive values. Like this. Therefore, natural log of our substitution is natural log of x. So natural log of natural log of x. Right? Like this. Plus c. That's the answer. But the interesting thing is for all of these problems, I used the same substitution. Why? Because of one reason. You can identify that. That's great actually. Let me show you all the problems. All of these problems, I used the same substitution, which is natural log of x. That's because of this x. You can try the fourth question actually. I'll explain that. Because this 1 over this x in the denominator is actually 1 over x. That's the derivative of the inner function. For that one, just one function. But here, the inner function, the derivative of the inner function. So that's the idea. I think you can try these two questions now using that idea. Try that. I'll explain in the next session. Okay, thank you very much.